my name is Monish and this is my Samsung project. My topic I chosen music and mental health. And then first we have to import the data from Kaggle. So first we'll install all the Kaggle dictionaries, and then we'll make a dictionary, and then we'll import the Kaggle API key so that we can install our data set from Kaggle directly to this link, and then we'll unzip it so that we can extract the data. Then we'll import pandas, and then we'll assign df as our data file. Here if you do df.head, you can see all the data that we have gathered here. Then if we see at this data, there's a lot of things that's not exactly correct. So first we see this timestamp. We don't need the timestamp of when they actually uploaded the data, and then we don't need this permissions. So what we'll do is just clean the data so that it's completely accurate data. So first we'll remove the timestamp permission. So this is our data again. Then we'll describe our data so that we can check for more errors. And then here we can see that the BPM is in weird values, in weird numbers. So we'll use a function called detect outliers. This function will detect if there's any outliers in the BPM value that we observed. And we can see that there's a lot of value. This is not normal BPM, and then there's sometimes 0. So we have to remove these detect outliers from this data set. So what we'll do is we'll just remove them using the list comprehension functions. Then we'll describe it again. So here we can see that this data is now clean, and then it's normal. Now we can work with the data set and represent it in charts or functions to get meaningful this thing. So first we'll represent in this thing hours per day versus age. Here we can get that which age group listens more music, and then which age group listens to less music. After 70, there's not a lot of people here. So from the data we gather, we don't observe so many in this thing. People after their 70s listening to music, and then people in 20s or something listen to music a lot of the time in the day. Then we do this thing, scatter plot using the facet grid of SNS. It's Seaborn inbuilt function. Here we can see that the same thing, hours per day and age. But then we'll assign different genre or different color, and then represent them in scatter plot, so that we can see which genre listens to more music and which age group listens to which genre of music. Then we'll plot this thing, BPM and density plot for different genre again, so that we can see that which genre has how much BPM. From this we can see that lo-fi music has less BPM because it's actually usually chill music, but then here EDM music has a lot of BPM. Then we can go here to see which primary streaming service affects depression, and then here it's almost all the same, so it's no difference. But when you check the same for insomnia and in Pandora, you can see that there's a lot of Pandora users who have insomnia. So what Pandora can do is suggest their users some uplifting music so that they sleep more and then cure insomnia. And then we'll see the pie plot of the same data of the primary streaming service to find out which streaming service is popular. From this we can say that Spotify is the most popular among everything, and then YouTube Music is the second, and then I don't have streaming service is the third. Then we'll plot the heat map to see correlation between anxiety, depression, insomnia and other mental issues with what kind of music they listen, what age they are, how many times they listen music, how much BPM music they listen to, etc. etc. Now we'll train an ML model to try to predict the data from the given data set. What we can do here is we import everything for the ML model. Then we we take X, which is our input data, so we don't need anxiety, depression, insomnia, because that's what we're going to predict. So we'll remove all 4 of them using df.drop. Then this thing, we're doing this to convert this thing X. Now when we see the data here, X has a lot of values I listen to Spotify, I listen to YouTube Premium, and then yes, no, which the computer can't understand. So what we have to do is convert this string into zeros and ones so that the computer can understand it and interpret it in the machine language. So this whole function, this whole function we're going to use to convert this thing into true or false, which this thing print dummies will show us the true false here. So this thing primary receiving service Pandora is listen to false. If they don't listen in primary, Pandora is false. If they listen, it's true, etc. And then what we do is we import TensorFlow and then we build a model. This is like a neural network, so we're adding layer upon layer so that we can give the input, and then the ML will predict the output depending on the layers and then connections the layers make using the neural network. We're adding like 1, 2, 3, 4, 5, 6, 7, 8. We're adding like 7 to 8 layers, and then we're going to see summary. Summary will just show us that how many layers are there and what is the output, like what it uses, etc. So these are the layers we can see, and then this just uses the optimizer to optimize our data and stuff. And then history model fit, what this does is it'll run variations. Like first it'll tell, it'll just give the data, and then it'll run variations like you try to use this chart to analyze this data and give this output. But then if it's like not accurate, it'll like here, at first the accuracy will be like 0.0 something, because the data is like new to the machine and then it doesn't understand anything. But then if you keep on repeating this process, the data gets more and more accurate. As you can see, at the last we are getting like 0.58 accuracy. So after running all these iterations again and again and again, we'll need to find the accuracy depending on the test model. So after the importing all this thing, we'll assign the test loss and test accuracy to evaluate this thing, test data, which we separated at the beginning. Then what we do is we predict this thing, Y prediction, using the X test data that we separated. Then we use the inbuilt function called prediction score and recall score to find out the accuracy and etc. of the data. And then what we do is print all the thing we found out using this thing. So as you can see here, after running some 4 iteration, it has given that the test accuracy is 0.57, which means that it's 57% accurate overall. That's all.